to another episode of Empower Apps. I'm your host, Leo Dion. Today, I'll be talking with Vojtěch and Werner from Cultured Code, the makers of Things. Gentlemen, thank you so much for joining me for today's episode.
Thanks for having us.
My pleasure.
Yeah. Before we begin, I'll let you gentlemen introduce yourself.
Okay, so I'm Werner. I'm one of the co-founders and the CEO of Cultured Code.
And I'm Vojtěch Rylko, but you can call me Vojtěch. And I am software engineer responsible for Things Cloud.
Awesome. So today we're going to talk about your story moving over to server-side Swift. Before we do that, you introduced yourself. Maybe you want to introduce Things and Cultured Code and the story of your company.
Yeah, sounds great. So currently we're a team of 11 people and we're spread all over the world, a fully remote company. Wasn't always like that. We have headquarters here in Stuttgart in Germany. That's in the southern part. But by now there's only 3 of us going there. The rest is all over the place. So we're fully doing that. And for the past 18 years now, we've been working on exactly one product, and it's called Things. And it's a delightful to-do app that you can use on all the Apple platforms. We're on all of them. And I guess some of the audience members might have heard of it or maybe even tried it already. We've been there from the beginning. The iOS app was there as one of the first 500 apps in the App Store when the App Store launched on iOS. And then we've continued that, like when the iPad came out, we were there on day one, and then same for the Apple Watch, and most recently the Vision. That's Things. We won 2 Apple Design Awards over this course of time, which made us very proud. Yeah, very happy about that. The most recent version of the app is Things 3. It's been some time since we shipped that. It was a complete redesign. So if you go to our website, that's the one you see. And ever since, we've been keeping it updated with all the latest features Apple adds to their platforms, new features we're building, and so forth. And so just related to this discussion, I guess I should conclude what we've also done is we have our own sync service, which we dub Things Cloud, and we've been running that for the past 13 years as well.
That's amazing. Excuse me. So today we're going to talk about your migration of Things Cloud to server-side Swift. What's kind of the backstory of Things Cloud and how that worked? Yeah. And also why have your own syncing service as opposed to iCloud?
Yeah, so back when we started, we've been at it for some time, as I said. There was no iCloud. There was on iOS there wasn't even core data back then. So when we built our app, we built our own layer on top of SQLite, and there we were, and our customers demanded that the to-do sync, of course, between the platforms. So we had to sit down and develop it ourselves. And so we did. And the first version of the cloud shipped 2012. Been running it ever since. And we're quite happy how it worked out. Like later in the game, Apple, of course, introduced other technologies we could have tried to use. But at that time, we already had a great running system. We actually invested quite some time making it, basing it on a very clear theoretical foundation that we're quite proud of as well. And it had proven itself already. Like our customers loved it from the day we shipped it, and it's they praised it for its stability and everything. And so why change that, right? Like today we're very happy to own this piece of technology. It feels great. So here we are.
I mean, you'd be handcuffing yourself, like basically, or restraining yourself to if you ever moved over to iCloud at this point, because you have so many. We'll talk about some of the features you guys have with the syncing tool, but yeah, it's pretty sophisticated stuff. Yeah, so let's get into it. What was it built with, and then why did you migrate off of that to Swift?
Yeah, it was, yeah. The legacy system was built using Python 2 and run in Google App Engine. And while it was pretty reliable, there were various issues we had, like the unpredictable performance, pretty long latencies, like the Python was not that performant. That led to pretty high monthly bill. And then it was pretty old, and then several deprecations loomed, and we had to decide what to do next. Like, yeah, yeah. So obviously, Python 2 became deprecated a few years ago. That was the biggest thing. But it was not only Python 2. It were also some frameworks we were relying on, and other technologies. So the simple path forward to just rewrite to Python 3 was not possible. We had to like rewrite, truly rewrite entire cloud.
That makes sense. So then what was that decision process like as far as what you were going to do next?
That's cool. Yeah. So yeah, we sit down on top, took blank paper and started from scratch, like thinking about which language to use, and all the options were on table. Like we're thinking Java, obviously, Kotlin, Go. We are also considering again the Python 3 and even C++. But then we realized that the Swift is also the option. Like it was not a common knowledge back at the time. Like we are talking about like 4 years ago when we are making this decision, and you didn't hear about people using Swift on server. Like the kind of companies, yeah, not a lot. Like the kind of companies like we are, small indie developers. There were zero success stories back at the time. We heard about Apple, for example, using that successfully internally, but it's a company with different kind of resources than we are. Uh, so so we looked at the Swift and its ability to run on server, and we are nicely surprised that it seems like it is possible, and not only possible, it compiled on Linux for many years already, and there was a server-side work group which was pretty established, and we started to get a little bit excited about this proposition. But of course, we're also pretty worried because the ecosystem felt not mature at the time. Like in comparison with, let's say, Java, it was still young technology. So we approached that with a caution. And but there were clear benefits to that. Like the Swift, we've been already using that for our client-side development for many years. We are used to that. It's fast language. It performs well. It has automatic reference counting for memory management, which makes memory management predictable. And it's a nice language, nice expressive type system, strong type system, which is great for maintainability of these larger systems. So all these benefits together took our attention, and we started to evaluate Swift on server. We started gradually. We started to play with some experiments. We're trying to run it, build some prototypes, proof of concepts. Always worried that we will hit some roadblock, some, I don't know, missing library. But that was interesting. That didn't happen. Like all these libraries were available. MySQL, Redis, AWS, encryption, like everything was available and it worked well. And so we started gradually building stuff. And over the course of 3 years, we are basically done with rewrite. And yeah, so that's why we got to Swift.
Mm-hmm. And maybe one thing I should add, just to paint a fuller picture of the past, the technology on Google side was Google App Engine, and that is a very high-level turnkey solution. And it served us very well in the beginning because you can get something going fast, which is what we needed. But over the time, as we were adding more features to the cloud, we kept hitting roadblocks where the black box nature really was in the way. There were performance issues that we couldn't explain. It was just lagging while accessing some data, or transaction sizes. There were various limits that we weren't fully aware of when we originally built it, and then we had to build workarounds for that in the old system, and so forth. Like it really dragged us down. Wojtek had to implement one such workaround, and it was nice. So we were in high demand internally for more control. I think it's not just about the language, right? Like the entire stack we wanted to be more in control of.
Yeah, I wanted to ask about that. Like, could you even like run Swift in Google App Engine? I mean, maybe now, but not at the time, I would assume.
Good question. I don't know.
I don't
Could you?
remember.
Okay.
Probably.
Yeah, but that, I mean,
Yeah.
that sounds like the basic motivation to get off of Google App Engine. So you did end up going with Amazon.
Mhm.
What were the other considerations you made as far as hosting was concerned? You had made the decision you wanted to host, you want to do Swift, and that was like, okay, where are we going to actually host this? Like, what was your decision process there?
Yeah, so I think the AWS is like kind of obvious leader here, or that how we perceive that, and it felt stable. It feels like they take that seriously. And I think the question is more like why not to use AWS? Like, what would be the reason to not to use that? We already had experience with AWS, good experience. We run some services there, so so we are familiar with that, and also their offering met our requirements. Like we are looking for where to run Swift and where to store data, and the database they offered and the way how they provide Kubernetes, everything made sense for us. So we went with AWS.
Yeah, that makes complete sense. And so, did you use EC2, or what did you end up doing as far as like actually hosting it?
Yeah, so we are using Kubernetes, but the EKS, the managed one. So AWS takes care for running Kubernetes cluster for us, and we are basically just plugging in EC2 instances. Currently, we have 4 EC2 instances. For some extra processing, we can always scale up. It's pretty convenient. And yeah, so it's running on top of EC2 instances in the Docker image. We compile Swift and bundle into the Docker images, which run in the Kubernetes cluster. And yeah, it's complex. The Kubernetes is complex, but it works well for us.
I want to take a step back because I know there's a lot of iOS developers who listen to this. Docker is kind of like a VM, basically a virtual machine that runs the application, essentially command line app that's a server. And then Kubernetes, is that like a way to run multiple Docker images and manage them, or how does Kubernetes fit into that?
Yeah, so I would say it's like operating system which spans multiple machines. So Kubernetes takes care of multiple EC2 instances. It manages them. It knows which are fine, which are crashing, for example. And if you tell Kubernetes to run this Swift executable 5 times, it will distribute it on the machines and make sure the networking is correctly set up so they see what they should see and the traffic is reaching them as you wish. So yeah.
And maybe in addition, what it also handles is the orchestration of when you're deploying a new update, right? There's a whole complex procedure where you have to stop traffic to the existing binary, bring up the new things already, redirect traffic, and so forth. Like all of this management is handled. And Kubernetes is usually like if you want to run that yourself, it's a whole team in your company doing that. And for us, it's two people on the back end. Your Wojtek is one, and then Maxim is the other guy. So that was not an option, but it being managed was certainly interesting, and it works fine for us, I would say.
Okay. What were some of the challenges you initially ran into in your rewrite to Swift that you had to like wrap your head around that Python made easy, I guess? What were you gonna say?
No, not really, right? Like there wasn't. I mean, you have to.
How was the maturity of other Swift packages compared to the libraries that Python provides? Like, I would assume that would have been a challenge.
So the challenge was our uncertainty about entire ecosystem at the beginning. We were approaching the Swift. We didn't know much about that, and we are very worried about, as you say, about maturity of third-party libraries.
Third-party libraries, because a lot of them are Apple or like, right.
Yeah, you are right.
Let's call them second-party libraries. Yeah.
Well, but let me quickly interject. Like you're right, Swift Neo, of course, is provided by Apple, and I should say, knowing that Apple provided that base layer of what we're building on top of was very important in our decision. Like that gave us a lot of confidence.
They actually use it day to day in their
exactly.
work. Yes,
yeah,
exactly.
Yeah. So that's great. And then, but there are other libraries from third parties that we're using, and that is unclear, right? Like how good will they work? Are they full of bugs? Are they crashing all the time, and so forth? That we didn't know, right?
Right. So, like, which framework did you end up using for your server?
So, there was almost obvious choice Vapor back then. So, and that got us pretty quick up and running. It was very convenient. Now we are, I think, a little bit outgrowing it, and maybe it's time to do it ourselves, to not use framework anymore, and but it still serves well. Like to this day, we are happy with that, and it's great for quick start.
Yes, I was going to say that if you're looking to start,
I
would highly recommend Vapor. It does a lot of hand holding for you to get up and running. Speaking of frameworks that you used, what other services are you using on Amazon for your application, and how does Swift fit into that?
Yeah. So the most important service is probably our database, and that is MySQL Aurora, which is kind of different MySQL managed and modified by Amazon, by AWS team. And it has different storage layer for data, which means that the data stored in MySQL Aurora are more durable. They are stored in distributed storage. And that was very important for us.
Which I think is a big difference from, I don't know what the Amazon one is. Not Dynamo. Is it Simple or what's the Amazon one that's just distributed but simple key value stuff? I forgot the name of it. But this is an actual relational database.
Yeah, exactly. For the developer's point of view, it's a regular MySQL with transactions, atomic commit, isolation. They're very nice features. Like we love them. That's why we wanted to use relational database. But we also wanted to have some guarantees about the durability of data. And there's not many databases with such high guarantees like the Aurora. This is very nice. Yeah. So if you commit a transaction and main instance crashes, you still have enough copies of your data. So Aurora has a different storage layer where they write your data to multiple locations, and that's a great feature. Like the regular setup of MySQL, if you want to achieve something like that, is to have two instances running, and you have a main writer instance, and you have some follower reader instance, which is building a copy of your data. But if your main instance crashes, now you have only one copy of data often. And yeah, so that's what I'm talking about. Like the Aurora comes with guarantees, which are true all the time.
And then so I want to cover, Sven had a question about any particular reason you went with MySQL instead of Postgres. Well, is it because Aurora is a fork of MySQL that's why you ended up going with MySQL and Aurora?
The main point, like there is Aurora for Postgres and for MySQL, but for MySQL, that one has been around for longer, so we felt it's more mature back at the time. So that's why we prefer MySQL, and also we were thinking that MySQL should better handle frequent writes. When you have wider table and you modify just a few cells here and there, MySQL should be more performant in this scenario. But I'm not sure if it's true even now, like this year.
So you might, like, if you were going to do it today, you might consider switching over to Postgres?
Oh yeah. Like I would consider that. I love Postgres.
But also, I guess we should say that we didn't run into major issues. Well, I guess we did have an issue with the size of the database, but I'm not sure if Postgres would have been much better there.
Who knows?
Right.
Like that's one of the surprising things we found is like you would assume that a few terabytes of data can be handled by these databases these days. I don't know. That was my naive thinking going into this. But we found out that no, actually you can't store terabytes of data. I mean, you can, but then you can't upgrade the instance, for instance, to a newer version because it just crashes while the update is going. And,
so how are you going to do that when they deprecate what you're currently using?
Yeah, exactly. So this is one of the surprises we encountered along the way. And then it's like, okay, I guess we have to solve this. And we went ahead and solved it by building a bottomless database thing. Wojtek, he did it.
Yeah, it was pretty late when we found this issue. Only once we had enough data in our database, we found we are not able to upgrade it anymore. So we built a mechanism for offloading of data from database to S3, which is like which we try to be opaque from the code point of view. And now we have a parameter which you are basically by this parameter you are changing how much of data we store in database and how much data we store in S3. Because storing in S3 is more expensive, there is more latency when you are getting the data. So we don't want to put all of data there. So we have a parameter, and if we need to upgrade the database, we adjust this parameter. It shrinks the database, offloads the data to S3, and then we can upgrade. But yeah, it was quite complex process we had to build, which we didn't foresee back then. It turned out well.
And maybe I should say, like when we're trying to solve these kinds of issues, I said in the beginning that we're quite proud of the way the sync works. And our whole approach to how we built it is to try to get to 100% correctness, not 99.9, because if your 1000th to do doesn't sync, that's a problem. you know. And so we care very much about correctness, and this now extends all the way to the cloud. And when you're offloading data from a transactional database into a different system, you have to be very careful to not accidentally break the transactionality here and the consistency of the data. And so we did spend quite some time engineering that, and it works great. Like another challenge is that in the database, each row is very small, right? And you can't just put each row individually into S3. That would be insane. So we compacted them together and so forth. Yeah, so it's funny. As I said, I didn't think we needed to solve that problem, but we had to.
So the database is in the server, but what part is in S3 and what part is in the actual Docker instance? Or Aurora, I should say. Or do you use Aurora and then you have the files in S3, or how does that work exactly?
Yeah, so we basically store all data in database, and there are like two parts, like two main categories of data. One part is the regular relational stuff, like user accounts, usernames, and like this obvious stuff. And then there's actual user data, their to-dos. And these guys, these to-dos, this content of for users, we don't care about the content on the server. It's a for us, for the server, this is like binary blob. As soon as possible, we compress and encrypt that and store in database. And we don't ever change, we don't ever mutate this data. So when user changes their to-do, we just add another record about the change on top of previous changes. So we are like building append only log for every single user. And that is a nice property, because if you don't mutate these pieces, you can put them somewhere else eventually. So if you have if you have enough of these, so they are worth putting to S3, you take them, put them together in some binary format we made, and we put them to S3 storage, where they are guaranteed to exist forever. And you can basically put a pointer to database in database to S3. But yeah, if you want to read the data now, you need to go through S3, which is slower, is more expensive, and you need to think about transactionality of whatever you are doing.
So you like all the to-do data is actually encrypted? Is that what I'm hearing?
Oh yeah. Like the way how things thinks is that the server doesn't do much about with data. Like it's all up to clients to understand data, to resolve conflicting situations, and the backend is like dump storage. Like it doesn't look into to-dos. There is nothing what we need to do there. So immediately when the change from user arrives, we just compress and encrypt that and put it into database as binary blob, and never look inside anymore. Like only when another client wants that, the client will read the data and look inside.
Okay, that's amazing. Wow. So you mentioned that you use S3. You also use lambdas, right, for some stuff?
Oh, that's a good
How does
point.
that?
Yeah, gives
Yeah,
you a
how does
library
that
that we
work?
needed from Python.
Okay.
Yeah.
Wojciech,
Okay.
you go.
And so we have a feature called mail to things. So every user of Things Cloud gets a special email address, where when they send the email there, it will appear as a to-do in their Things inbox. So we are receiving these emails, and we need to process them somehow on server to create a to-do for the user. And processing emails is that's a mess. Like so we are processing incoming emails with Lambda, where we run a Python 3 script, because Python has the best libraries for this kind of like messy work. where there are internet standards, but nobody really follows them. So you need very mature libraries to be able to parse any email, any incoming email. So yeah, so we still have some Python around.
But it's very much a satellite, right? Like it's just this little thing that runs in Lambda. The majority of the code is in Swift inside Docker, running on Kubernetes or managed by Kubernetes. Yeah,
Is that the only Lambda you have? Is the
I think so,
email?
right?
Okay.
Yeah.
Okay.
Mhm.
That makes sense. Yeah, we did that episode with Sebastian talking about Lambda and Swift stuff. So yeah, it's a pretty powerful tool. You have also like some background processes as well. Those are written in Swift. How does that work? And what do you use it for?
Yeah. So we have a bunch of background workers, and they run in our Kubernetes cluster as every other stuff. And what might be interesting is that we have one code base and one shared code, and we are building just one binary, but it can be configured to run as API or as the worker of type A or another worker. And one of these workers is exactly that database offloading. So there is a worker which is reading the database, looking for data which it can offload and put to S3. So this is one of these workers. So it's the Swift guy. Another is the worker which takes these processed emails by Python and actually creates the to-do for particular user, like looks for the user and creates the to-do. And we have a bunch of such workers.
Do you use like what is it, service lifecycle stuff, or how do you trigger that, or how do you get it running?
Yeah, that would be great. Like we would love to use this, but we still have some legacy stuff built on top of event loops, and
Okay, got it.
that part is a little bit messy.
Um, I will ask later about Swift 6, but before I get into that, I think one question I should ask that I think is important is you've got an app in the App Store, you've got a server on AWS. How are you sharing code between the two? And like, have you seen advantages with that, I guess? Because that's the big question is like, okay, you've written an iOS app, you have the backend in Swift too. Is there any shared code in that instance between the two, or what advantages have you seen in that way?
Yeah, so that's very interesting. Even on the client side, right? It's not just one app; it's multiple apps that we're shipping. One for the Mac, one for iOS, and one for Vision now. And even there, the story is that the code bases have started out quite separate. Like we used core data on the Mac, but our own thing on iOS, and hence entirely different models and entirely different view stacks and so forth. And so in the past, ever since we've been around, we had this effort of unifying more and more of the code base. Like today, the same model runs everywhere. By the way, yeah, and even a lot of the controller code, all the logic code, the sync code, of course, is shared across the platforms. And there's even more we want to do on the clients. And back when we decided to try out Swift on the server, the possibility of code sharing was certainly an interesting prospect. So that was part of the reason why we were excited to use it on the server. Now, so far, that has not come to realization. Like we're not sharing code, maybe one or two files that I forgot, but the majority isn't shared. However, we think in the future there will be quite some opportunities for code sharing. And so I guess we'll have to chat again in a few years, and then we have a more interesting perspective on that, I think.
Yeah, I think like for me, it's always ended up with like simple data models. Those are the ones that end up being shared, or maybe like some utility functions and things like that. But yeah, I mean, your business logic is different on both, and yeah, I could see how that would not be as as useful as you might think. Is everything in one? Is everything in like one Xcode project or multi-repo, mono repo?
I mean, for the server, it's all in one, and then for
Right.
the clients, it's all in one.
Okay, so you've
we have
kept
two.
that totally separate. Okay,
Yeah,
interesting.
Yeah. Mm-hmm.
So I'm going to ask the awkward question here. Swift 6, where are you with that? Are you excited? Are you scared? What's kind of the thought process with Swift 6?
Actually, we just recently we switched to Swift 6, and yeah, and we like that we were yeah. Yeah, so for server, like we adopted structure concurrency everywhere. Now we are just waiting for that few remaining dependencies to to catch up. We completely switched to Swift testing, and it went pretty well. Like I don't know, like we spent like 1 or 2 weeks adopting the structured concurrency, and there were no on the server. Yeah, I'm speaking about server, and there were no major roadblock or something. Just like some sendables here and there, some changes, but it was pretty nice experience on the server.
It's almost easier on the server than it is on the client
It
in a
is,
lot of
certainly.
ways.
Like, that's why I
Yeah.
was correcting, like, only on the server it took 2 weeks. I think on the client we invested more. And it was certainly more in the way on the client, I would say. On the server, it's very natural because
Right,
already the
right.
structure is like you're getting the
Event
requests,
loops and
you're
all that
isolated.
stuff.
And,
Yeah, we've had that for a while, so it's like, yeah.
Yeah.
Let's talk about. Well, is there anything you're interested in when it comes to Swift 6.1? I may as well ask that if you've even looked at it.
Yeah, not I'm not particularly like excited about any features. What I liked is that Swift language committee acknowledged that this concurrency is sometimes a little bit tricky, and they are trying to work on more approachable Swift concurrency, and that excites me. I think that's a good direction.
Yeah, agreed. Let's talk about logging and metrics. How important is that when running a server application, and where did that fit when it came to Swift?
Oh, that's super important. Like without being able to observe what's happening, we are not able to detect that something's wrong. So as Werner said, we are a team of just 2 on backend, but we have pretty high standard even for such small team. So for example, we have pager duties, so we have or all the call duties. So we have like we have monitoring, which triggers incidents, and that incidents wake up current developer who currently has on-call duty. And for that to work well, we need great monitoring, logging, metrics, everything. So we can set up incidents which notify us only when something's really wrong, and we need to be able to detect all the potential issues. So I think the logging is that's probably even the biggest part of our cloud bill currently. Like just the logging and metrics, that's the most expensive part currently. So we take that pretty seriously, and we are using custom JSON logger we built, and we are using the Swift Prometheus package, which is available and which ships the metrics. And we are watching the efforts about tracing and other stuff. I think currently there are some people working on this, so it's on our radar. Yeah, Prometheus is a way how to. It's about metrics. It's about metrics. So currently, with Swift Prometheus package, our code is able to provide various metrics, and these are then digested to CloudWatch, AWS CloudWatch, and then where we can see nice graphs, and we can set up some, I don't know, incidents if something is over some threshold and so on.
So there was something you mentioned really piqued my interest. Speaking of listening to issues and errors and things, is this thing called a chaos engine? What is that exactly? What's going on there?
Yeah, I think the best testing is testing on production. So so the chaos testing is a way how to test the infrastructure and a little bit also the code on production. It's about introducing various faults, injecting faults into the code or into infrastructure. So for example, every morning the chaos engine we have injects some fault into cluster. It can be that some of instances crashes, like we force instance to crash, and we observe if it auto heals and cluster like gets into the health state again, or we have some part in the code where we force unwrap nil, and we do that every now and then and see if we are properly notified about this happening and that no no issue happens like to data, or like that everything gracefully recovers again. So
is this like cron job, and is this all written in Swift
yeah,
or?
so it's quite weird beast. So it's powered by cron. So every day it starts, and it's like a shell script with shell scripts, and we are using various ways. There's, for example, AWS service which helps you to inject particular subtle errors, for example, networking errors. And that's very useful to test. Like you can test the split brain scenario, like what if you disconnect your cluster to two parts, what will happen? So all of that is super, super interesting.
And maybe I'd like to add to that. Like before, we said Google App Engine was a black box for us. That was the downside. The upside is that they did a pretty good job at having a great uptime of the Things Cloud service. And so throughout the years we've been using that, the uptime was phenomenal. And so when switching over to this entirely new cloud where we wanted to have more control, one of our worries was, well, we better make sure that we have the same level of quality that we're delivering to our users. And we went at great lengths to ensuring that the chaos testing is part of it. Like, how do you know how your system behaves if things go wrong if you don't make them go wrong, right? So we try to do that. And then the other part, of course, is it's an entirely new stack, entirely new code base, new technologies everywhere. How do we know that it works well? You know, that we're not constantly having some crashes and so forth. And that was a big challenge when developing. And we can get into that if you like. But we went at quite some lengths to ensure that on day one, the new version we're shipping is already tested in production. So yeah, just as a small side, we basically ran both versions side by side. That was the trick there.
How did that work out? Like, or how did you keep both in sync and stuff?
Yeah, it's quite cool. We think that's quite cool. So Wojtek, here you go.
So when we are developing new system, our goal was to not disrupt users on day one. Like we needed the new system to be very robust and already proven before releasing. And we found that the only way how to make it is to run it actually. And so we had a legacy system running, and we started to run a new system alongside, and we piped all the traffic through the new system, where it executed its own logic, its own database access, it stored the data, it performed all the Swift code there, but it also forwarded the requests to the legacy system, and that where this was authoritative. So the response from legacy system got back to user. It's impossible to keep these two systems completely in sync, so they diverged in the data, like what's in database. But that was not really important. Like the correctness, we tested the correctness and behavior manually and by other ways. But the fact that it worked all the time, like for a year, without downtime, without crashing, without performance issues, that gave us confidence that once we turn off legacy system, it will work fine. And to make even more sure, we employed the chaos testing, where we not only let the new system running, but we were also poking into that and seeing like if it auto recovers, how does it behave under extra load and similarly. And we're observing the system for months and months before we got enough confidence to actually switch over to it.
So before we close out, I had one more question: was how do you actually deploy your server app? So those of us who are iOS developers are quite familiar with dealing with the App Store. Server side is a bit different, and I know you talked about using GitHub Actions and things like that. You want to explain how deployment works when you want to update the server?
Yeah, it's actually pretty boring. So GitHub Actions, they come. You're right. So we compile our Swift code or using GitHub Actions. Of course, it could be faster. That would be very nice. But it's about 10 minutes, and that.
Do you run their server? Do you run their? Well, no, I guess you run Linux, so you don't even need a Mac.
Exactly, like GitHub provides you with runtime, so you just like create a small YAML file where you specify a few steps and they are executed. It's very convenient. And so we build our Swift code base there inside the Docker, so that creates a Docker image, and that got uploaded in a fancy storage like Docker registry, but it's just like you put it somewhere, and it has a tag attached, like some name, some tag. And then when we want to deploy that thing, we basically tell Kubernetes to use a new tag, this new tag, and Kubernetes takes the image, shuts down the old running service, and starts a new one basically. Or you can do it can make it also gradually. It can like keep old stuff running, starts also new stuff, and start switching the traffic so you have no downtime. That's also sometimes useful.
That's awesome. Before we close out, was there anything else you wanted to talk about?
I mean, maybe just throwing a top level light on this whole endeavor, right? Like, why are we here? We feel that back when we started this project, as Wojtek said in the beginning, it was quite uncertain thing. Like, will it work out? Will it not work out? And I guess along the way, we grew in confidence. Like, there was no roadblock along the way. There were no problems to speak of. And now even in production, it's been in production for a year. We haven't said that yet. Like, we switched early last year, and it's been running great. So we consider this a great success story for Swift on the server. And we felt that it's important to get the word out, because there's not that many still great use cases out that people can listen to. right? So that's why we went to the Swift on Server conference and had a short talk there to tell people it's like, hey, it's working. Like if you find yourself in a similar position as us, maybe you already have a Swift code base and you need a server component, this is definitely an option. Go try it, right? Like, or at least consider it.
And we'll have links to your talk and my success story from Swift on Server as well, and some other folks.
Yeah.
Definitely check that out.
Yeah. There are some, of course.
Yeah. All right, but everybody knows things, so that's I think that's a big defining feature for the part of your story is that. I don't know how many users, gazillion users use things. So we know it works. We know it works.
That's about the number,
yeah. It's a scientific number. For someone who is an iOS developer, which is the vast majority of Swift developers, maybe they won't need a server. Maybe they're just kind of curious about having a server. Why should they get started on server-side Swift? And how should they get started on server-side Swift?
Yeah, that's interesting. Like, I'm not sure that we are in position that we could give good advice here, because we are quite a backend people, like me and my colleague, so who just know Swift. So we use Kubernetes and everything, but I can't recommend it for anyone who just want to try. It's pretty complex, and it took us lots of time to set up. Is like full-blown, like full-in solution, full-in approach. For somebody who just starts out, I don't know, maybe you already said about something about the Lambda. Now you can run Swift on Lambdas, so maybe for some small, minor server processing, that makes sense with some managed database, some key value store. That could be maybe interesting. But I would definitely, if I would be iOS developer who just want to try out, I would be looking for some managed solution where I don't need to care about EC2 instances and Kubernetes and nothing like that.
I like Heroku. I've used Heroku for most of my stuff.
Yeah.
You just get a Vapor app, put it up. It's pretty easy to get started. Vapor is a lot of hand-holding, great documentation.
Yeah, definitely. I mean, we that's how we got started as well, and it was great.
Right. Before going down the rabbit hole of Docker and Kubernetes,
exactly,
and all that stuff.
I think
so.
That's a great.
I do think like having some experience with server-side development is helpful. Just getting that perspective, as far as like what the other side does, is besides doing just table view controllers all the time. There's more to it outside of that. So yeah. Anything else you wanted to mention before we close out?
Not sure. Not from my side.
Okay.
Nothing from my side.
Gentlemen, thank you so much for coming on. I really appreciate it. This has been fantastic to hear your story, your success story with server-side Swift. Where can people find you online?
Good question. Culturedcode.com. I guess us personally, Wojtek, I don't know.
The best site, culturedcode.com.
Awesome. And we'll put links to your social stuff in the notes too. So yeah.
Technically, I have one. I mean, you should follow the company. That's where we communicate. Like I technically have a social account, but I'm not really using that
much. Thank you so much, gentlemen. It's been fantastic.
Thank you. Thanks for having us.
People can find me at brightdigit.com. My social is at LeoGDion on all the socials, at LeoGDion@c.im on Mastodon. Thank you again. I look forward to talking to you in the next episode. Bye, everybody.
Thank you. Bye.
Bye-bye.
Bye.